Hey there, sixth graders. Today we're going to take a look at a few strategies for us to be able to compare fractions. Now these strategies are thinking smarter, not harder. There will be kind of a safety net strategy that we will eventually learn by creating common denominators. We're not there quite yet, so we're going to take a look at some other methods that we can use where we don't need common denominators. Now, these methods won't work all of the time, but when they do work, when we're given fractions, for instance, that do indeed have common numerators, these methods work really, really nicely. So let's dive right in and take a look. We're going to model some problems and see how the methods work. So if I have 1/4, let's go ahead and model that. To create quarters, you cut it in half and you cut your halves in half. So here's 1/4 and 1/6. I'm going to go ahead and cut it in half. I need 3 equal pieces on both sides, so I'm going to create thirds over here and thirds over here, because that will now give me sixths, 6 equal pieces. I'm going to shade in one of them. Now, as we can visually see, this is a smaller piece than this. 1/4 is indeed greater than 1/6. Now, a lot of kids when they're young get a little confused because they think, oh, 6 is bigger than 4, so 1/6 must be bigger than 1/4. I'm not just talking about 6 whole things or 4 whole things. We are not thinking about this in terms of whole numbers because we're not dealing with whole numbers. We're dealing with fractions. And what this means, the 4 and the 6 mean, hey, I'm taking one whole thing and I'm splitting it up into 4 equal pieces. And then 1/6, the 6 does not mean 6 whole things. It means, hey, I'm going to take one whole thing and I'm going to split it up into 6 equal pieces. Now, the more cuts you make, what happens to the sizes of your pieces? Envision if you just cut this in half, you created 2 equal pieces that are pretty big. Thirds are also pretty big. Quarters, fifths, and sixths. The more cuts you make, the smaller your pieces become. So if we have the same number of pieces, so I have 1 piece in this case, and I have 1 piece in this case, what I can now do is compare the sizes of the pieces. And as we discovered in our last lesson, the smaller the denominator, the less cuts you're making, which means the bigger the pieces. So in general, when you have the same numerators, or the same number of pieces, we can compare the size of the pieces, which is determined by our denominators. Okay, so we're going to take a look at the sizes of those pieces. Common denominator route, that's when we're given these nice, pretty easy fractions in which we're given the same denominators. So if I'm given the same denominators, it means that my size pieces are exactly the same, in which case I will just compare the number of pieces that I have. So let's go ahead and model this. So fifths, I'm going to take my finger and put it at the halfway mark, and then I'm going to draw lines to either side of my finger, and then 2 more, and that will create approximately equal fifths. I go to either side of my half, and then I'll go ahead and cut those in half, and I have created 1, 2, 3, 4, 5 equal pieces. 2 fifths, I'm going to shade in 2 of them. 3 fifths, I have the same size pieces, but in this case I have more pieces and they're the same size pieces, so 3 fifths will be more. So these are the easy ones. If you have common denominators, you're going to compare your numerators and see which one you have more of. So in general, when you have the same denominators, what does that mean? That means the sizes of the pieces are the same, and that makes our lives easier. So we're just going to compare the number of pieces that we have, aka also known as the numerator. So that's a pretty easy method. Let's take a look at the 1/2 benchmark. Again, this doesn't work all the time, but when it does, it is a really, really, really nice method. And in fact, it's probably one of the first methods that I work through in my brain when I'm comparing 2 fractions. Okay, so we have 3/4 and 1/3. Let's go ahead and model these. So 3/4, I'm going to break it in half and break my halves in half. That creates quarters. 1, 2, 3. And 1/3, I'm going to put my finger in the middle And I'm gonna create lines to either side. That creates thirds, and I have 1/3. Okay, we're gonna go ahead and compare these to 1/2. 2 quarters, if I have 2 out of 4 things, I have half. And 1.5 thirds, 1.5 of these thirds is equivalent to half. As you notice, as you may see, 3 quarters, you have more than just half. 1/3, you have less than half. So if one of your fractions is bigger than half, you automatically know it's bigger than the other one if the other one is less than half. So we know 3 quarters is bigger than half, and we know 1/3 is less than half because, and why are we using half? Well, we're using half because you boys and girls are actually very good at figuring out what fractions are equivalent to half. If your numerator is half of the denominator, then your fraction is equivalent to 1/2. They are equal. So if one fraction, if the numerator is more than half of the denominator, that whole thing is more than half. So again, in this case, we know that half in terms of quarters is going to be 2 quarters because 2 is half of 4. And we know 1/3, or excuse me, 1/2 in terms of thirds is 1.5 out of 3. 1 is, over here, 1 is less than your 1.5, 3 was greater than your 2, which is how I was able to so quickly compare my fractions to 1/2. And then we have another nice method, doesn't work all the time, but sometimes works. It's called the one-hole benchmark. The one-hole benchmark, we're going to compare our fractions to having one whole thing, and we're going to see how many pieces away from a whole that we have. So let's model these first. So 1/6, I'm going to go ahead and break it in half. I have to break these up into thirds and these up into thirds. I've got 5 of these. And then 3 quarters, I'm going to break it in half, and then break my halves in half. 1, 2, 3. Okay, so if we are going to compare these, I'm noticing something in common. What I'm noticing is that this is one piece away from having a whole thing. We have one gap until we had the whole thing. This is also one piece away. If your two fractions are the same number of pieces away from a whole thing, what we can do is we can compare the sizes of these gaps. So how far away is this? Well, this is 1/6 away from a whole thing. And this guy, my 3 quarters is 1/4 away from a whole thing. So now let's go back to that idea of comparing 1/6 to a quarter. 1/6 is a tinier sliver than 1/4, which means it is a tinier gap away from a whole thing. And here's my whole mark, right? If I had the whole thing, I'd be at this finish line right here. This is so much closer to that finish line than the 1/4 has a bigger jump because 1/4 is bigger than 1/6. So this 5/6 is closer to 1, which means it is bigger. So my 5/6 is greater than the 3 quarters. So again, we're just kind of summarizing what I already worked through. How many pieces away from 1 is 5/6? Well, it was 1/6 away. But then our 3 quarters was 1/4 away. This ended up being a bigger gap. That was a smaller gap, which meant this was closer to 1. So this works, again, only sometimes, only when they're the same number of pieces away. So to compare our fractions to one whole thing, we can only do this if we're the same number of pieces away. If both are the same number of pieces away from 1, then we can compare the size of the pieces or the size of the gaps. Okay, and the one that is a smaller gap is closer to 1, which means it's bigger. So let's go ahead and take a look at it at the back side of the notes, and let's do some examples. And we're going to go ahead and use some of these methods that we just learned. 2/3 and 1/6. And a lot of you boys and girls in class have been saying, "Oh, I just know it." Well, I want us to use these methods and justify our answers by using the methods. 2/3 and 1/6. The first thing I think about is my 1/2 benchmark. Let's see if 1/2 benchmark works. If I have thirds, half of thirds, in terms of thirds, I should say, is 1.5 out of 3. And sixths is 3/6. Those are equal to half. 2/3 is bigger than half. 1/6 is less than half. So I'll go ahead and label that this is bigger than half. And this guy is less than half. So my answer is made easy. Then this is obviously bigger than this. If this is bigger than half, this is less than half, then this is the one that's bigger. So we just used our 1/2 benchmark. I love that method. Okay, 2/9 versus 2/7. I'm noticing that I have common numerators. So I have 2 pieces and 2 pieces. Let's compare the sizes of the pieces. This is smaller pieces. Oops. Because the denominator is bigger, because I'm making more cuts. These are larger pieces because the denominator is smaller, which means you made less cuts, which yields bigger pieces. So 2 of these bigger pieces is bigger than 2 of smaller pieces. That was our common numerator route. 4/10 and 4/5. Okay, again, I'm seeing common numerators. Tenths are smaller pieces than fifths. Oh, and actually I think 2 work out here. So these are bigger pieces. Okay, so we know that 4 of the bigger pieces will be bigger, so that's common numerator. But I also have 1/2 benchmark at play here. 4/10, well, 5/10 is equal to half. 2.5 fifths is equal to half. This is also more than half. And this guy is less than half. So my 1/2 benchmark also works in this case. So the 1/2 benchmark is also a good strategy for this problem. And I'll work through one more with you. 2/3 and 3/4. Let's work on the 1/2 benchmark first. That's usually the first one I look for. Well, as well as common numerators. I don't have the same numerators. That doesn't work. I don't have the same denominators. Oof. Well, let's see the 1/2 benchmark. This is more than half, but this is also more than half. So I can't use the 1/2 benchmark. Let's see if we can maybe use our 1/2 benchmark. I think this will work. In this case, I am 1/3 away from 1/2 thing. And then here, I'm 1/4 away from 1/2 thing. Okay, so 1/3 versus a quarter. Think about a jump of a third to get to the finish line versus a jump of a quarter to get to the finish line. The jump of the quarter to get to the finish line is smaller, which means it is closer to the finish line. So that is 3/4 is bigger. And I'm going to quickly draw a picture just to really reinforce this. Make sure your models are the same size to start with. 2/3, 1, 2, quarters, 1, 2, 3. As you can see, the quarter jump is smaller than the jump of 1/3 is bigger. So we are closer to the finish line with 1/4. It's a smaller jump to get to 1/2 thing. So that is how we can compare those two fractions. I challenge you to finish the rest on your own, and you can check my completed version of the notes to check your answers.